All right, in this next example, we've got a rational function greater than or equal to a constant that is not zero. To solve this inequality, again, I need to find the zeros just like we had before. But I can't find the zeros until I have 0 on one side of the inequality. So I'm going to subtract that 2 from both sides of the inequality. That gives me 3x minus 5 over x plus 2 minus, now I'm going to write that as 2 over 1, okay, just to make it a fraction. Now, to combine these in order to get a single rational function, and of course I've got greater than or equal to 0 here, I need to multiply top and bottom by the x plus 2, right? So I'm going to do that, x plus 2 to the top, x plus 2 to the bottom. My new fraction on the right will be, well, that 2 will distribute, so that will be 2x plus 4 over x plus 2. And then I can combine these two rational functions. So the main idea is to get a single rational function and compare it to 0 on the other side. So I'm trying to get these together. So I'm going to get 3x minus 5. Then this negative distributes to both terms. So I get minus 2x minus 4 all over x plus 2. And when I combine my like terms, 3x minus 2x is just x. Negative 5 minus 4 is negative 9. All over x plus 2 is greater than or equal to 0. Okay, so here's my final rational inequality. The solutions now to the original inequality and this new one are going to be identical, okay? Same solutions. We've just changed it, so now we're going to be finding the zeros of the numerator and denominator so we can compare to the number 0 using a sign chart rather than trying to compare to the number 2, which is much harder to do. Okay, so to find the zeros, I take the numerator, set it equal to 0, I get 9. Remember, the numerator gives me x-intercepts. The denominator, set that equal to 0, I get negative 2. And remember, the denominator gives me vertical asymptote. In this case, there is no shared 0, so there's no hole. Okay. Again, my sign chart is going to have those two numbers, negative 2 and 9. The negative 2 is a vertical asymptote, and so I'm going to use a dashed line, just so that in my mind I can remember that that's not going to be included no matter whether I have the equal or not in here. And then the x-intercept is going to be solid. Again, that represents including the endpoint when I have the equal sign here, which I do. So I'm going to include that 9 if I need it. Okay, so now I'm going to take and plug in numbers in each of those 3 intervals. So we'll start maybe with a negative 3 because that's less than negative 2. I'll throw 0 in there, that's in the middle interval, and maybe 10 out here on the right. Okay. When I plug those in, I'm going to plug them in to this final inequality because that's where I'm comparing the rational function to 0. Okay, I'm not really interested in the value 2 here. So if I plug that in, I plug in negative 3, right? Negative 3 minus 9 will be negative. And negative 3 plus 2, well, the negative wins out, so that one's negative. And when I divide them, negative over negative is positive. So my final answer there, all of those outputs will be positive. When I plug in a 0, 0 minus 9 is negative. And 0 plus 2 is positive. And so the ratio of negative and positive is a negative. So that means everything in the middle there will be negative for outputs. And when I plug in the positive 10, 10 minus 9, well, that's a positive. And on the bottom, 10 plus 2, well, that's also positive, which makes a positive ratio. So every output from the right interval will be positive. Now, in my final answer, I'm looking for all values greater than or equal to 0. So those again are the positive ones. And so when I look at my intervals here, I've got two intervals that will work for solutions. They are everything less than -2. Again, excluding the -2 because it's a vertical asymptote. And then everything greater than or equal to 9, this time including the 9 because it is an x-intercept. Okay, so that gives us our final solution. Every x value in these two intervals will solve the original rational function.